let's start to the first question. So this is a trig substitution. How do you know trig substitution? Most of the time when you have a root, something minus something, root. Can you see? Can't you see all this question I've got root? Except this one, which I'm going to show you how to solve it. This is not trig substitution. This is trigonometric integral. That's why you say trig substitution and integration. Okay, you see this one? You have a root, number minus or number or variable minus number. Can't you see all of them? They cannot have the same. Oh, so whenever you have this type of structure, then you know this is a trigonometric, because that could be the equation. Sometimes people ask me, how do I know this is a trig integration? That's how you identify. So now, how am I going to know this is going to be sine, this is going to be cosec, or this is going to be sine, whatever, and this is going to be sine, this is going to be sine, this is going to be sine, and this is going to be tan? How am I going to identify? So let me show you something quick. This is very, very important before you get started, right? So, look here. If you have a format of, don't worry about the ratio itself. If you have this format, let's say x squared minus a squared. If you start with the x, and then you know this is going to be sec. If you start with the x. So, then you say x equal to a sec of angle. Okay, what happens when you start with a? Okay, if you start with the a, so don't worry about the ratio start on this, like, see here, like this one here, x start means this is going to be sec. Okay, what about this one? When you start with the a can be any number. So this is going to be x equal to a, this is sine. When you start with the a sine. Okay, now let's go for the last one. For the last one, if it's like this or other way around, because when you say 1 plus 2, it's the same 2 plus 1. But when you say 2 minus 1, it's not the same as a 1 minus 2. That's why they give us two different things. But for this one, either could be a squared plus x squared or other way around. This is going to be tan. So this is going to be x equal to a tan of angle. See? Now, another thing also you have to know, trig identity. Okay, so what do you mean about that? Okay, you need to know this one. Sine square angle plus cos square angle equal to 1 always. But from this, I can produce another identity. What do you mean about how? How? Okay, I'll show you now. I can divide everything by cos here. Divide everything by each one by cos square. I should say that. Okay, sine square divided by cos square is going to give me tan. Cos divided by cos 1 equal to 1 divided by cos square equal to sec square. Oh, so now I have a identity. So I need to write this identity because I'm going to use them from now to the end. Okay, so let me write this identity because I'm going to use them tan square. Let me write here tan square plus 1 equal to sec square. Okay. Let me write big a little bit just in case you cannot see. I'm going to use them. Okay, tan square plus 1 equal to sec square theta. Okay? Also, the same one I can divide by sine square throughout. Okay, if you divide by sine square throughout, what is going to happen? To show you something here. So if you divide by sine square throughout from the key identity, if you divide by sine square, it's going to give you 1 plus, okay, plus cos square divided by sine square is going to give you cot. Okay, 1 divided by sine square is going to give you cosec square. Oh, so from the same identity, divided by sine square is going to give me that. So I can write aside because I'm going to use that too. Right here because I'm going to use this one. Okay, 1 plus cot square, 1 plus cot square equal to cosec square angle. Okay, cool. Now let's go to the question number 1. So now we have all we need. Let's go to the question now and see how we can apply it. Okay, question number 1. So this is going to be sec. Because we say whenever you have a variable minus a. Oh, that's going to be sec. So I'm going to say integral dx, okay, x squared minus a squared. Oh, they want us to, okay, easy. Okay, so I'm going to say this is going to be sec because it's variable minus. So I'm going to say, so I'll say let x equal to a sec angle. differentiate dx equal to, when you differentiate this, it's going to give you a, and this is when you differentiate, it's going to give you sec theta, tan theta, d theta. Okay, let me do this, d theta. Yeah, this question number 2, sorry. Okay, so let's replace everything. So this is going to become integral. We know the value of x. What is x? Our x equal to a sec theta dx. We know dx equal to a. Oh God, it's finishing. The pens are finished. A sec theta tan theta d theta. Okay, we over. Okay, now x squared. What is x squared? X squared equal to me a square sec square minus a square. So this is going to give us sec square minus something. Sec square minus 1 is going to give you tan square. But remember, there's a root, means it's going to give us a tan. So the answer, all of this is going to be a tan. But let me show you how it comes about. For some of you may not understand, you may get confused. How? Look, a square can take a square out, and then here is going to be sec square minus 1, but all of them they have a root. When you square this is going to give you a, because you can separate. So of a equal to a, and then sec square minus 1, look, equal to tan square. Or mother identity, sec square minus 1 equal to tan square. But when you square tan square, it's going to give you tan. That's why it's going to be a tan. So all this is going to be a tan. So then it's going to become integral a sec theta, and then it's going to be a sec tan theta, a sec theta tan theta, and this is going to be a tan theta. And then we have our d theta. Okay, some of the stuff they're going to cancel. For example, a is going to cancel with the a. Okay, tan. Let's go for tan. So for tan and tan is going to cancel. So I'm going to be left with a sec theta d theta. Oh, so there's going to be integral of a sec theta d theta. I can take a out. A is going to go at the back. So it's going to be a integral of sec theta d theta. So this is going to be equal to a. But when you integrate sec, it's going to give me ln of sec theta plus tan theta. But now we're not done yet, because in equation they did not give us in terms of theta, they give in terms of x. So how are we going to replace this theta with x? So let me assume a little triangle here, okay? Let's draw a small triangle. If you have a little triangle like this, so this is theta. Let's use what they have given to you. Look, they give you x, what we let from tricky substitution. X divided by a. X over a equal to sec. But what is sec? Sec is 1 over cos. So I can replace the sec by 1 over cos. For a reason. 1 over cos. Let me flip everything. It's acceptable. This could be x over a over x, and then cos over 1. So if I flip everything, this let me say a over x equal to cos theta. So I'm going to use these to come and substitute here, because I know from Triggy, from SOHCAHTOA, I'm going to know, okay, cos equal to adjacent, which is going to be a for this case, over adjacent over hypotenuse. So hypotenuse is going to be x. And cos adjacent over hypotenuse. So I can get the opposite. How am I going to get the opposite? The opposite here is going to be x squared, because it must be this square minus this square. But we're going to have a root. So for that case now, I can use those tools. I can just erase this and come and replace the sec. Do I know the sec? Oh, of course, yes. Sec equal to x over a. Oh, so I can say this equal to a ln, and this can be sec equal to x over a, and the we plus tan. What is tan? Tan equal to opposite over adjacent. Or opposite over adjacent. Then for that case we plus c. So for that case now this can be a ln x over a, and then we plus. We can just put them together because they all both have a common denominator, and this is going to be x squared minus a squared, and we plus c now. So the question is done. Means if I integrate this, it's going to keep it there. Let's go to the question number 2. This one is done. So I got my watch here. I didn't have a watch for past days, so I decided to put my watch so I can see how fast I can go there. Don't forget to check my previous video, okay? So I've done a video where I did break some records. There's another one I took for 6 hours non-stop. I did it for the Africa continent, with my African dashik. Make my Africa proud. Okay, let's go. Now let's go to question number 2. Question number 2, okay, it's a very interesting question, but it needs a lot of space as far as I see. So let me do the ratio that will come here because you need all over this place. So let's keep this pending. We'll come back for it. Let's keep this last question. Let's go question number 3. Question number 3, they give you integral and they say 1 over x squared, and then you got 64 minus x squared. Okay, so this let me say, okay, what is 64? 64 means 8 squared. So okay, so this let me say 8 squared. Now let's let. Which one you're going to let? This is going to be signed because it's number minus x. Just like how when we started. See? So x minus number minus x. Oh, so I'm going to say now for that is let x equal to 8. Mean take this number alone and they say sine for this case. Okay, differentiate dx. When you differentiate, you get dx. When you do this, it's going to be sine and it's going to be cos or theta, d, theta. They place everything here. So integral, let's go. So now, remember there's a dx here, forgot. Dx is, what is dx? Dx equal to 8 cos theta, d, theta, x. What is x? X equal to 8 by a square sine theta, because you square this, right? You see, we must square, okay, square root 8. 8 is just 8 square minus x. X equal to x square, so 8 square and then sine square. Okay, now what we do? Okay, this one here is going to give us 8 sine. Okay, look, let me go. I know it's going to be 8 cos. You know, I think you know from the first one. So I'll do all of this. The ratios half, I'll just do automatic. Look, this is going to be 8 cos. You want me to show you how to do that? Okay, so this is going to be 8 square, and then I can say 1 minus sine. But 1 minus sine equal to cos square. So, and then I can say this is equal to cos square. Okay, when you square it, it's going to give you 8. When you square it, it's going to give you cos. Cos theta. That's what I say it's 8 cos theta. Okay. So we got 8 cos theta. So then this is going to become integral. Okay, 1/8 and 1/8 go. So here's going to be cos theta d theta. We left with only 1/8 in the sine square theta, and this is going to be 8 cos theta. Okay, cos theta cancel. This is going to give us 64. So 64, 1 over 64 is going to go at the back because this is 1 over 64, and the integral for 1 over sine square d theta. But what is 1 over sine square? 1 over sine is cosec. So so for that case, it's going to be 1 over 64, and it's going to give us cosec. 1 over sine cosec here. Cosec square theta d theta. Integral. But when you integrate cosec, you get negative cot. So this is going to give us 1 over 64, but there's a negative what? Negative cot theta. Okay, so we're not going to leave an answer like that. That's going to be seen unacceptable. So you have to go to that small triangle. Okay, look, this is a small triangle, let's show. So use this one here. So this is going to be divided by 8 divided by 8. So this is going to be opposite, and this is going to be hypotenuse. You see what I'm saying? It's going to be hypotenuse. And that for that case now, we can get the adjacent. How are we going to get hypotenuse square minus opposite square? It's going to give adjacent. So we want to get cot, but what is cot? Cot equal to adjacent over opposite. It's like the inverse of tan. So for me, I can do straight away, say 1 over 64, but our cot equal to adjacent over opposite plus my c. You know how did I know that? Because I know tan equal to opposite over adjacent, but a cot is the inverse of sine. Oh, I can just show you if you want to know. Okay, look, this is like -1, but what is cot? Cot, I can say 1 over tan, and this is 64. Okay, now look how we're going to get it. 1 over 64. We still have a minus. Okay, now what is tan? Tan equal to, I just show you, but we finished already. Just for some people don't know what is happening. Tan, what is tan? Tan equal to an opposite over adjacent. But what happened? This is going to go to the top. That's why this top here went to the top here, and they will plus c. This is went to the top, and they will plus our c. So we're done with that question. Okay, we go to question number 4. Okay, question number 4. Oh, I said I was going to show you that one. So this is not trig substitution. This is just normal trig integration. So this, let me show you how we can approach this. It's easy. So we're going to say It's not easy in a way. Let's see. So I'm gonna break this. So cos. So this let me say integral of cos. Did I say cos? Let's make sec, because cos is gonna be way easy. Let's make sec. Let's make sec. Let's make this sec. Let's make this sec. Let's make this sec. Cos is gonna be way easy. Let's make sec. Okay. So this is gonna be sec. Sec, and this is gonna be sec. So it's gonna be sec cube equal to sec x and then sec square x dx. So let this equal to u, because this is going to be integration by parts. You don't know by parts, go to my other video, just search integration by parts. On my video, you're going to learn by parts. So this is going to be integration by parts, you know, is u dv equal to uv integral v du. So u is going to be this. Okay. Later u equal to sec du equal to, when you differentiate sec, you get sec tan. Sec x tan x dx. Okay, now let's integrate this one. So we're going to say dv, which is this one, dv equal to sec square x dx. Integrate and integrate. So v equal to, when you get dv, you get v. Okay, when you integrate sec square, you get tan. So now we're going to have to substitute in this equation now. Okay, integral u v dv means this one. This is the same as this or that one. But let me take that one. So say sec cube x dx equal to uv. What is the u? U equal to sec and v equal to, so it's going to be tan x sec x. Sec x minus, okay, now we go v. What is a v? V equal to tan x multiplied by du. Du equal to sec tan. So sec x tan x. So this tan x I'm going to multiply, it's going to be tan x squared, and then it's going to be sec x dx. So you can do slowly, but I will just say this tan this tan is going to be tan squared, and then we still have our sec. Now what we're going to do now, I can replace this. Tan squared equal to tan square, look, tan square equal to sec square minus 1. So for you, you can just do next step, but for me, because the space is not enough, so I can say this equal to 1 minus sec square minus 1. So I can say tan square equal to sec square x minus 1 dx. And then what we're going to do, okay, multiply that out. So this is going to give me sec cube and sec. So this is going to be integral of sec cube x dx minus and minus, okay, let's say, okay, this is going, okay, let me do this. This is going to be minus, this is going to be, no, let me do slowly for some people. I don't know how to open the bracket. Okay, so this is going to be minus integral of sec x dx. I hope you understand. So when you integrate sec cube, oh, we cannot do that. So now what we're going to do, let me show you how. So here we have integral of sec equal to, and then you have a tan x sec x. So you know what I want to do? Let me open face. This is going to be negative, this is going to be plus. So this is going to be plus, and this is going to be negative. It means I open the bracket. So look, see this one here and here, the same. So I'll take this to the left so that they can join together. So like red 1, red 2, like look, this and this are the same. So I'll take all this to the left. They're going to be 2 integral of sec cube x dx equal to tan x sec x minus integral of sec. But when you integrate sec, you get ln absolute sec x plus tan x. Okay, so we got this. So what we're going to do now, they don't want that. They just want what? To get integral of sec cube. That's what they want us to solve. They don't want 2. So divide by 2 throughout. Divide by 2 divided by 2. So there's going to be 1 over 2, and this is going to be all this divided by 2. So 1 over 2. So I'm going to remove this because from the question they say find integral of sec cube. So sec cube is to have tan square, or you can say this the same as say tan x sec x over 2 with the plus or plus. All this stuff ln of sec x plus tan x over 2. Same thing. Or you can put 2 as a 1 over 2. However you think it's going to be convenient. Okay, this is going to be integral of sec cube dx. So we're done to go to question number 5. Let me see if it does record first, so make sure. Oh yes, it does record. Okay. Question number 5. Yeah, let me go quick now. More quick. So number 5, I know this. Okay, first I'm gonna have to rearrange my stuff. Okay, so this is gonna be signed, but let me show you how I'm gonna rearrange. Du. Okay, we got u here, and then have a So now look, this must be in the form of a square, not as a number, because from the formula it has to be as a look. So I'm gonna have to write the form of square. If somebody give you 5, and if somebody say 5 square root and then square, the same thing. But this one is in the form of, because if you use this, it's gonna give 5, same thing. So this and this is the same thing. But the reason why I restructure like this, because I wanna be able to do the substitution. This is gonna be 5. Okay, and then minus u squared and then du. So what we're going to do now, we can let. So let u equal to, this is going to be sine. So take a number which is inside the bracket here, which is equal to 5. Okay, and then after that, we can differentiate. When you differentiate u, you get du. And then when this you differentiate, it's going to give you the same thing, it's equal to 5. That's going to be cos of theta d theta. Substitute back. So integral du, what is the du? Du equal to square root of 5 cos theta d theta, and then over u, our u we know, square root of 5 sine theta, square root of 5 bracket minus, my pen is getting finished, okay? Minus u square, what is the u square? U square equal to that one. Okay, so now I'm not gonna do that. How did I get this? I'll just do straight away. So this is going to be, okay, this and this is going to cancel, so this is going to be integral cos theta, and this is going to be sine theta, okay? When you, this is going to be, okay, square root of 5 is going to be, square, okay, and that's going to be cos, but I want to know the number here. Okay, look, if I take 5 here, like this, it's going to be 1 minus. Oh, we got this one, okay. So now, okay, I understand now. So this is going to be 1 minus sine square equal to cos square. So this is going to be like cos square. Okay, and now this, look, this and this is going to be like 5, but we still have a root which is outside. And this is going to be square root of cos square x. And this is going to be square root of 5. And this is going to be cos of theta. But you can do slowly, you get there. Okay, you can separate this root. Okay, so this is going to be square root of 5 cos theta. Square root of 5 cos theta. Okay, with 5 cos theta. So now we say, now we are saying, so this, okay, cos theta, so this is going to be d theta. So now then, I can take square root of 5 outside. So cos and cos cancel. So 1 over square root of 5, which is this one, went outside the integral. So now I'm only left with this and this cancel. So 1 over sine theta d theta. So this is going to be 1 over square root of 5. Okay, so this I may say 1 over sine equal to cosec. 1 over sine equal to cosec. No. I don't have to do that. I can say ln. Because when you integrate sine of x, I forgot to integration. When you integrate sine of x, it's going to be ln. Because 1 over something, look, integrate 1 over f of x, how do you do? Dx. This I may say derivative this 1 over prime, it is a ln of whatever which is in here. But you write your absolute plus c. So same here. So this is gonna be you can okay, so this is gonna become okay 1 over this is gonna be ln, because you have to derivate one of the functions is going to give you 1. So ln of whatever is in here. Okay, so then our final answer, but we don't want to leave our answer is a sine. 1 times anything is that something. So I can write this square root of 5 underneath, e for 1. But then we have to replace this, because we don't want it to be like it. See? Excuse me, I was just checking. Okay. We don't want it to be like that. So then what we're going to do now, we're going to come to a small triangle. So this is going to be our theta. Now we come here. So sine equal to opposite over hypotenuse, which is equal to 5. And we don't know this one, but we can get this one. How are we going to get it? We can get this one. How are we going to get it? I'm gonna take square root of this one square, which is going to give us 5, minus u squared. So now, then, there was no need for me to do this, because I know sine of theta equal to u over square root of 5. So this let me say ln absolute u over square root of 5. This is sine of theta sine of theta, and then we're going to plot c, but all this stuff is 1 over, let's go to 5. So this is going to be my final answer. Please check out this one for me, okay? One, just simple table. But I don't know how black feeling. Maybe I made a mistake, maybe. So check it out for me. Let me know when the video, if you watch it, that was right. Only that one. Okay. And then right under the comments, okay? Let me know if I made a mistake or not, but I think I did correct here. Okay, cool. Now we go to the next question. Okay, so next question, which question? Question number 6, yeah, question number 6. The one with the limit. Oh, that one is it. Okay, now we go, so this is going to be sine also because it's number minus, okay? So we got integral, and then we have a 0, a, and then we got x squared here, and then we got a squared minus x squared dx. So I'm going to let here, let x equal to a sine, because this format is a minus a sine. Okay, differentiate is going to give us dx equal to a cos of theta d theta. Substitute. So limit. So for now, let me just leave a limit, because if I use this limit after substitution, it's going to be wrong. Leave the limit. Okay. X, we know. What is x? X equal to a squared. So don't worry about the limit. Leave the limit for now. We're going to substitute again. X squared, so it means a square, x equal to a square sine square theta. Okay, now come here, square a square is a square minus x equal to this, means x square equal to a square, because all of this you must square. Okay, dx, what is dx? Dx equal to a cos theta d theta. But this meaning integral a square sine. Okay, this meaning a, because this is going to give you 1 minus sine square equal to cos square. It's going to cos square equal to cos. But also a square, when you factor out, it's going to give you a cos theta. You can do slowly. A, and here we have the a cos theta d theta. Now let's finish up. So now it's going to be a power 4. So there's going to be a power 4 and the integral. Now we got this, so it's going to be sine square and then cos square d theta. So now we can replace that. So let me make everything cos cos, or let me make everything sine sine, you know, and then do it as a trig double angle. So I'm gonna say now, okay, this let me say a power 4, okay, and then I can just say integral. Let me make everything cos or sine, whatever. Let me make everything cos. I prefer cos. So this is gonna be 1 minus cos, and this is gonna be cos square theta d theta. Okay. Now you can multiply that out. This is going to be cos square, cos power 4. So cos square and cos power 4. So this is going to be a power 4 integral of cos square theta d theta minus integral cos. Let me do like this. This is the best way of doing it. You know, power 4. Because I know this, I can come and substitute as a double angle. So what does double angle say? Double angle say if you have a cos, double your angle. This let me say. Let me say 2 cos square of your angle minus 1. So I want to replace this cos square, especially whenever you have an integral of the cos square. You don't need this square. You must replace your double angle. See this square or sine square. So I can say, okay, what the meaning of cos square? Cos square means this one come over. It's going to be cos plus 1 over this 2 equal to cos square theta. From double angles, you know this from the trigonometry. So now I'm going to say, okay, so now let me replace this one. So it's going to be a power 4, and then a power 4, and then this one is going to have to go. Means it's going to replace it with this. But a 2 is going to go at the back, so it's going to be 1 over 2, and then integral of cos 2 theta plus 1. So it's going to be cos 2 theta plus 1. Going to be d theta, but also this I can separate. You can say integral cos 2 theta d theta. Okay, let's go step by step first. Okay, so then I'm going to say this half is for both of them. Okay, now I'm going to say minus. So now this is going to be integral, but you got to pay attention here. So this is going to be 1 of 2 is going to go at the back. So I can say this is I want to be very, very careful here. So I don't want to mix up stuff. Okay. This a power 4 is for both. This one is this. Now minus minus, so I'm dealing with this now. Okay, let's step by step. So this is going to come, it's going to be cos 2 theta plus 1 over 2. Okay, but I can take these 2 at the back. And then, but remember, there's a square here. No, if I do that, I'll be wrong. I must write my 2 here because I have to square my apology for this case. And then have a d theta. Now, you have to expand it. So if you have to expand this is easy because, okay, let me finish this side and then we deal with this. So, oh, I can just, okay. I can just erase it because, okay. Okay, we go. So now we say, we say we cannot take it out because we must square. Okay. So now let's count for this one. Let's finish this one first. Let's deal with this one finish. Let me deal with this one and finish, and then we can put them together. If I take these separately, okay, let me get down with this. So it's going to be, look, if somebody gives you integral of cos function, what you do is say 1 over differentiate f of x is going to give us f prime. And then when you integrate, so differentiate whatever is here, f prime, and then integrate cos to get sign of your function given plus c. So for that case now, that's how you do all the time. For the people who are new, who don't know what's happening. So for that case now, I'm going to come and then integrate the cos. Okay, let's see, this is a power 4. Okay, this is going to be 1 over 2. Okay, now, differentiate is going to give you 2. So that 2 is going to come in here. Differentiating the right answer under here. So 1 over answer. But remember we have another 2 here. Okay, and then when you integrate cos of 2 theta is going to give you sine. Okay, plus plus. Now you come here. This is like integral of 1d theta. It's like integral of 1d theta. It's like integral of d theta, which is going to give us theta. But d theta, remember you have a half. Half times theta is going to be theta over 2. So this is going to give a theta over 2 because this half is for both. Theta over 2. So now for the first part here, we're done. 2 times 2 equal to 4. So this is going to be 1 over 4. So you guys, we're done with you. So we come here. But here you have to expand this. This is going to be called, okay. This needs a space alone, okay? So I can say, let me deal with this separately, in a separate case. But in exam or whatever you do, you must show exactly what you do. So this is going to be, okay, so I'm going to say plus and then, okay, let's take this one. Okay, so first and foremost, it's going to be integral. It's going to be cos plus 2 of them plus 1 when you expand it over 4. 1 over 4 is going to go to the back because it's going to be 4, 4 is going to be 1 over 4. And then here we have a d theta. So I can separate each one separate. And I'll say 1 over 4 integral of this. Okay? Integral of this, but this is a double angle. From the double angle, if I take this equal to this, it's like, look, if somebody give you cos square, just like I said before. Some people don't know me. That's my concern. Some people may not know what's happening. Okay, this was, okay, let me say here. Cos, let me say, cos theta square, it was equal to this one, which is a cos what? 2 theta plus 1 over 2. What about cos square 2 theta? Cos square 2 theta means like cos, now square, but here is 2 theta. If this is 2 theta, this is going to be 4 theta. It's going to be cos of 4 theta plus 1 over 2 from tricky double angle. So what I'm going to do, I'll replace this with that. So it's going to be integral, okay, cos 4 theta. Okay, this 2 is going to go to the back, so 1 over 2. Okay. Okay, d theta. Now I count for this one. Now when you go for that one, for this, when you integrate this, it's going to give just like the previous one. Okay, so when you integrate this one, well, so this one for the first one, this one for the second one, is going to be integral. We got 2 here. Okay. I'm going fast a little bit. Okay, this is going to be integral. So 2, I can take this 2 out, and this is going to be cos double angle d theta, but 1 over 4 is for both. Okay, and then you apply for all, not for both. Okay, so integral 1 d theta is like d theta. Okay, so now this can get done. So now we can integrate this. It's going to be 1 over 4. Okay, let's start with the first one. It's going to be 1 over 2. And this is going to be, when you differentiate, this is going to give you 4. 4 times 2 equal to 8. Okay? And then when you integrate cos, you get sine. Now we go for the second one. Integral of 1 is going to give you theta. Okay? Integral of 1 d theta equal to theta, but times a half equals theta over 2. Now plus. Now we come for this one. This is 2. We have a 2 for both. So this is going to give you 2. Okay. Differentiate is going to give you 2. 2 over 2, which is going to be equal to 1. So I don't have to write anything because 1 over 1 equal to 1. And then, okay, 2 over 2. Let me just show you. Okay. And then when you integrate cos, you get sine. So this equal to 2 or 2 equal to 1. That's what we're saying. Okay. With plus, this is going to give you theta. But all of them multiplied by 1 over 4. That's what I say you need a lot of space. Okay, multiply this is going to be 1 over 32 sine. And then plus theta over 8 plus sine over 4, and then plus theta over 4. So this and this we can add together. If we add together, you can use a calculator. Okay, 1 over 8 plus 1 over 8 over 1 over 4. 1 over 4. Okay, 3 over 8. So 3 over 8, 3 over 8. So this is going to give us 3 over 8. It's going to be 3 over 8. So I can remove this, I can write this 3 over 8. So all this stuff is going to come in here, and the question is going to be almost there. Okay. So now I'm going to come and replace some stuff here. I'm going to say plus. Okay, plus. Okay, this stuff here is going to come in here. So it's going to be 1 over 32. 1 over 32. 1 over 32 sine 4 theta. The plus 3 theta over 8, and then plus. Okay, sine over 4. Okay, so for that case now, we're going to take that one and then multiply it out. So I don't need this anymore. Okay, multiply that out. Oh, I don't have to multiply that out. What I have to do, I have to get the value of theta, and everything. And then the question is going to be done. So this is going to be 8 power 4. 1 over 4. Sine theta is like 2 sine theta cos theta. Or I can just do this aside and then come back and substitute. Okay, let's do this. Same trick like I did for the last one. Okay. Let's go to the given question. This is the question they give to us. Let's draw a small triangle. So this is going to be a small triangle here. Okay. This is going to be opposite, and this is going to be hypotenuse. So this is going to be hypotenuse square minus opposite square. Now what do we want? We want to get the value of theta. What is theta? Theta equal to sine inverse of x over a. So, but here, sine of double angle equal to 2 sine angle cos angle. 2, what is sine? Sine of angle equal to opposite, we know sine of angle x over a. Okay, cos of angle. Cos of angle equal to adjacent over hypotenuse, so equal to a. So all this stuff here is going to come in there. You see what I'm saying? So we're going to come and replace this with this. Okay, now what we want the value of theta? Theta equal to, look, x over a equal to sine theta, inverse. Okay, so theta equal to sine inverse of x over a. So this stuff is going to come and replace that. Now let's come here, sine of 4 theta. So sine of 4 theta. Okay, so this sine of 2 theta, right, which give us that. Now they come with the sine of 4 theta. Sine of 4 theta is easy. Because how am I going to look? I'm going to say sine of 4 theta equal to 2 sine 4 theta equal to 2 sine 2 theta, and then cos of 2 theta. Sine of 2 theta, I know. Sine of 2 theta is this one. So this is going to come in here. And cos of 2 theta, I can get it too. You see what I'm saying? I'll come in, get cos of 2 theta. Sine of 2 theta also I know, and then you finish up the equation. I was supposed to take this and that together, and then I don't have to repeat the process. So you take this stuff here, substitute in here, that's the end of the equation. Because even this one and this, you can put them together. This and this, you can put them together and then substitute back. That's going to be the end of the equation. You see? Now we go. I believe you can finish up there. Now, just substitute because of the space. Okay. Now you go to question number, that was question number 6. Oh, we forgot the limit, and then you substitute the value of lower limit. Okay, let's assume there's no limit. Because with the space and limit is going to be a problem here, my God. But I believe your name. Let's check first if it does record. I'll make sure all the time. So we go to question number 7. Yes, it does record. Okay, question number 7. So they give us this one. Okay, integral. Integral, we got 0 to square root of 3 and then x cubed 16. So you see this question you can do 2 ways, either by normal substitution, or if it's not substitution, then you can do trig substitution. I can show you both methods. Okay, normal substitution, because sometimes it's optional, unless if they say do by trig or do by substitution, because sometimes they can recommend it. Let me start with the normal substitution. Look, I can let you, because if I say let me let you inside, no, if I let this inside, then the derivative is not going to give me this. But if I let everything, is going to give me that. Look, I'm going to say let u equal to 16 minus x squared square root. Or what that means? This is like u equal to 16 minus x squared power half. Differentiate du equal to the half is going to go to the back because this is going to be half, and then this is going to be like this. And then differentiate this is going to give you negative 2x dx. Look, 2 and 2 cancel, and then I'll take negative to the back, so it's going to be negative du for a reason. You're going to see now. Okay. So can't you see x dx 16 minus? If I separate this x and means this negative du. You see? So then I'm going to say leave your limit for now. Okay, so x dx is negative du. So negative will take back and then du. And then this x square, I'll show you now how the x square comes about. From here, look, square. When you square this side, it's going to be u square. Square this side is going to give 16 minus x squared. If I want to get the value of x squared, I can get it because this is going to come to the right. It's going to be x squared equal to 16 minus u squared. Oh, so this is going to be x squared. The value of x squared equal to 16 minus u squared. Can't you see? The question is finished. And now we're going to say this is same as say negative. When you integrate this, it's going to give you negative 16 u, and then minus and minus plus. And this is going to be u cubed over 3. Now we can replace those u's because they didn't give us a question in terms of u, in terms of x. So finally, this is going to be equal to negative 16. What the value of u? The value of u we know. U equal to 16 minus x squared. And then minus plus u we know the value of u equals 16 minus x squared. This is power cube over 3 plus our c. No, they give us a limit. What is the limit? Let me start from 0 to square root of 3. So what we're going to do now, the question is finished, but I just have to substitute. Substitute upper limit minus lower limit, always. Substitute upper limit minus lower limit. And that's going to be the end of the question. If you do by substitution. But they might say, hey, do by sign, because this is, you can do the sign here. Which I'll personally, I'm not going to go that route. Because this is going to be bigger number. Look, imagine you say sine q. Bigger. So I'm not going to go that route. I'll just do normal substitution. Unless they recommend it, you should do by sine. Because imagine this is going to be sine q. But it's done. I'll show you now how we can do. Okay. Upper limit. Take this, substitute everywhere there's an x, like here, and then get the answer. An answer you get your minus. Take this, substitute everywhere there's an x, and then get the answer right here. And then subtract, get the answer. I believe you understand. That's how you work with the limit. Take this limit, substitute in the position of x here and here, and then get the full answer right here. And they say minus, because you must say upper limit minus lower limit. That's how I say. So now we take a lower limit, plug in here like 0. It's going to be 0. So it's going to be negative 16 minus square root of 16 equal to 4 times plus, put 0 here. Get the answer. And right here, the subtract. That's going to be a final answer of everything. Now, let's do by tricky substitution now. Same question, let's do by tricky substitution. We want to see how that's going to become or how it's going to turn to be. But personally, I'll take this route because this seems to be easy for this question. Okay, by tricky, we know this is going to be sine. So for sine, means we say this is going to be this is going to be x equal to 4 because the 16 is 4 squared. 4 sine theta. Dx equal to, differentiate is going to be 4 cos theta. D theta. Okay, substitute. So leave the limit for now. Integral x dx, x, we know. X cubed. So for now, let's leave x cubed because we separate for some reason. X cubed means it's going to be 4. 4 cubed is going to be 4 times 4, 16 and 64. And then we say sine cube. Okay. Dx, what is it dx? Dx equal to 4 cos theta. Cos theta d theta. Okay, this stuff here we can get because it's going to be 16 minus 4 sine square. 4 sine square, which is going to be 4 cos. It's going to be 4 cos. You can substitute slowly, but you know why I say that. For now, you should know. Okay, this and this one cancel. 4 and 4 cancel. So we have this. 64 go at the back, so it's going to be 64. And then integral of sine cube theta d theta. I can separate this. So I'm going to do that. This let me say 64. And I can say sine square. And then another one, sine d. Okay, now this is going to be 1 minus cos square for a reason. I'll tell you why I do this. I'll say 1 minus cos square. So instead of say sine square, say 1 minus cos square because of my space, but I show in exam all the steps. 1 minus cos square, but I use show. Okay, and then I'll say let u equal to cos because I know if I let this, if I differentiate, it's going to give me this by normal substitution. When you differentiate now, this is going to be du. Let me see if it does show there in the screen. Oh yes, it does. When you differentiate, it's going to give you du equal to, okay, when you differentiate cos, it's going to give you negative sine. Theta d theta, which is this. But the problem, you take negative to this side. Because it's sine theta d theta. So what I'm going to do, I'm going to say, let me replace everything with a u. So now this is going to become, this question, it's going to become, we got 64 here. Integral 1 minus, what is cos? Cos equal to u, we say, but it's going to be square. Sine theta d theta equal to negative du. Okay. It's going to be negative du. So then we finish because this is going to become negative 64 integrate 1. We're going to get u. Because 1 du is just a u. Minus. This is going to be u squared. When you integrate u squared, you're going to get what? U cubed over 3. Okay, so for now, we're not going to say plus c because we need to check back to how it was before. So we know the value of u. What is the value of u? U equal to cos theta. So this is going to become negative 64, and this is going to be cos, okay, let's do like this. Cos theta minus cos cube theta over 3. Okay, if you want, you can, okay. So then we say, we can replace this stuff now because we don't need them. So if you use tricky, the answer is mine. I don't think the same as the first one because use another substitution. So they're gonna recommend say use tricky or use normal substitution. So then I'm gonna say I can draw my small triangle like how all the time I do. My small triangle, okay, from here. This is gonna be opposite, and this is gonna be hypotenuse. So adjacent is gonna be 16 minus x squared. So what is cos? Cos meaning we know cos. Cos equal to adjacent over hypotenuse. So now this is going to be equal to negative 64. What is adjacent? Cos equal to adjacent over hypotenuse, which is going to be 16 minus x squared root over hypotenuse equal to 4. You see? And then we minus the same thing but with a cube now. So let me write here finally because the space is not enough. So let me just come in right here. So say negative 64. Okay. Okay, this is going to be 4 and 4 is going to give us 16, negative 16. 6 4 is going to give you negative 16. Okay, so we don't need this anymore because we divided by 4. This divided is going to be negative 16. Okay, now we minus. Okay, this one is going to give you negative positive, so it's going to be positive here. 64 over 3. Now we come cos cube. Okay, so by cos we know equal to, what is the cos? 16 minus the x squared over 4, but this must be what must be? Cube, and then we plus c. So that question is done. So if you had to use a tricky substitution, then this is how you could have done. So you can learn from how to do things, okay? And if you identify any little or silly mistake, then you can work with that, okay? Say, oh man, you forgot to say this is supposed to be minus, this is supposed to be plus. That's what I'm here for, okay? And I can learn from you too. Excuse me. Now let's go to question number 8. This question is very big, you need a lot of space. Maybe I'm going to do it separately because the space is very small here. You need a space. That question is actually bigger than the one that I just did now. So I'll copy and then I'll do separate. Okay, now we go to question number 8. Question number 8. Okay, question number 8. So we say, okay, integral. Okay, we got square root of 2 and then 2. Okay, and then dt. And then t cube. And then we got t squared minus 1. So let this is going to be sec. So it's going to be 1 t equal to sec of angle. dt equal to sec tan. Substitute. Integral. Leave the limit for now. dt. What is dt? dt equal to sec tan t cube. T cube means sec cube. It's going to be sec. Now this is going to be t squared minus sec squared. Oh, I think I made a mistake here. Did I? No, we're not t. T is going to be sec squared. Okay. So this is going to be sec squared minus 1. What is sec squared minus 1? Sec squared minus 1. Sec squared minus 1 equal to tan. Equal to tan. So all this stuff equal to tan. So I can just say integral sec cube tan. Okay. This and this one go 1. Okay. So I want to say integral 1, and this is going to be sec squared, and this is going to be tan over tan. I think I can simplify the sum here. What is tan? Tan meaning okay, let me just simplify. It's like a 1 over sec. Sec is like, okay, 1 over sec equal to cos. Cos squared theta times, okay, 1 over this equal to cos squared. I want to simplify first. Tan means sine over cos, and this cos can go to the top. It's going to be cos cube. Oh, okay, cos cube. So it's going to be cos cube over sine. Okay. Tricky one. If I say 1 over tan, no, it's not going to give to me. Okay, this is a very tricky question, very interesting question. Let me see if I did everything correct. Now, did I copy correct? Yes, t cube, t squared minus 1, t squared minus 1. Or, if I do normal substitution and I take this, no, it's not going to give to me, okay? Equal to t squared, okay, sec tan, substitute sec tan, and then this is going to be sec cube. Tan, of course, yes, this is tan. I want to make sure everything is correct. This and this cancel. So this and this one cancel. On top, I'll be left with tan. Where is my tan here? I forgot tan. Because if you cancel this, so I forgot something here, my apology. That's why it's kind of weird a little bit. It don't make sense, okay? Okay, this is going to be integral. So this is going to be sec. What is sec? Sec is just a sec. Theta, and then I got tan theta, and they got sec, and this is going to be tan. Okay, this and this cancel. And one, yeah, of course, because look, this is going to be tan. So tan and tan are going to cancel in 1 second, 1 second. Oh, that's how many mistake in 1 sec. That's what just kind of weird. Integral of 1 over sec. Okay, 1 over sec, it's a lot of wicked. Okay, 1 over sec is integral or cos square. Okay, then this is done. Because this is a trig, no more substitution, double angle. So this I may say integral of cos double angle plus 1 over 2. If I have to replace this from the double angle for trig. Okay, now 1 over 2 is going to go back, and then we can integrate separately. Okay, integral cos theta plus 1. Okay, so this will be 1 over 2. Okay, when you integrate this, will give you 1 over 2. So 1 over 2, this will be 1 over. Okay, let's do this. 1 over 2 sine. Okay, this will be theta. It's going to be just a theta. So this let me say 1 over 4. 1 over 4 sine theta over 2. So it's not done yet because the question they did not give us in terms of theta, they give us in terms of t. So we have to replace this with a t. Just like how we did before, small triangle. Oh my god, okay. This is theta, so they give us sec. Sec, ooh, we don't need that. Okay. Sec is 1 over cos. Sec, so they say here sec equal to t. But what is sec? Sec is like 1 over cos equal to t. But t is like table. We can flip everything. So it's like say cos equal to 1 over t. So this is going to be adjacent and this is going to be hypotenuse. Adjacent equal to 1, hypotenuse equal to t. We can get an opposite because opposite equal to hypotenuse square, which is t square minus adjacent. So now we can get all this stuff sine double angle. What is sine of double angle? Sine of double angle we know. Okay? So I want to say 1 over 4, 2 sine theta cos theta. This is double angle of sine plus theta over 2. So 1 over 4, 2. What is sine theta? Sine theta, because this theta equal to opposite over hypotenuse. Opposite equal to hypotenuse equal to t. Cos. What is our cos? Our cos equal to adjacent over hypotenuse. Adjacent equal to 1 over hypotenuse equal to t. Plus. Now theta. How are we going to get theta? I can just inverse this. It's going to be theta equal to sec inverse of t. So it's going to be sec inverse of t. Sec, because I can just inverse sec inverse of t. Sec inverse of t. Okay, but over 2 plus constant. Then if you want, you can just say this is t squared. If you want, it's just a matter of simplification. This and this is going to give us, if you multiply in, it's going to give us only 1 over 2. And then when you multiply into 4, right? Multiply 4 is going to be 2. I think it was 4, yeah. It was 4. Yeah. No. It's going to be each one 1 over 4. Yeah, 1 over 4 multiply, and now you come 1 over 4 multiplied by this is going to be 1 over 8. Sorry. Okay, cool. So we're done. Except this 260 squared, but I believe you understand how it goes down. Okay. Now we go to question number, which question? Question number 9. Let's see if it does record. That's very important for us to check if it does record, so I don't waste time like how I did past days. Like I did today, I wasted the whole hours. Okay, cool. Now we go to question number 9. Question number 9. Integral 1 x squared minus 1 Okay, so what we're going to do, Okay, so we know this is sec because it's x minor. So say let A. Oh, I forgot to substitute the limit for this question, but I think you know how to substitute upper limit minus lower limit. Now we go for this question. Let me just ignore the limit, but you know how to substitute. So A equal to, x equal to 1 sec. Okay, differentiate dx equal to sec theta tan theta. Substitute. So integral, leave the limit. So this will be x sec minus 1 dx equal to sec tan theta. Okay, now this is going to give us tan theta. It's going to give us tan theta. Integral tan theta. Tan times tan is, this is going to give it tan theta, but tan times tan equals tan square. And here is just a sec theta d theta. Okay? But this one here, I can say this is, let me say, what is tan square equal to tan square, tan equal to sec square minus 1. So this will be sec, but we have times sec square, times sec theta. And then for that case, now we say, multiply this out, it's going to be sec cube, integral of sec, integral of sec. This one we know. Oh man, what is that? I did somewhere here, this one here. So you can work it out this and plug it there. Or if you want me to do, I can do it again, but I believe you know how to do it by parts. Okay, so I'm not gonna do this. I'll just say this is like saying sec minus. This one we know equal to non sec plus tan. Okay, sec plus tan. Theta. Okay, if you want me to do, I can do that. What would you suggest? Should I do or should I leave? Oh, we know how to do because I'll get the answer here and then I come and substitute. But then, if you want me to do, I can do, no problem. But I believe you know how to do it. So I don't waste the time for your time. Now we come for this one. So this is by part because say u equal to this one and this dv. When you differentiate, it's going to give you, when you differentiate, you sec tan. So this is going to give us sec tan, and this one you integrate, sec square is going to give you tan x, tan theta for this case. And this is going to give you du sec theta tan theta. Let's see if it does record, it shows everything. Of course, yes. So this one here, I know. If you want me to do it, I can do that for you here. And then we plus this one. Or if you know how to do, then I can skip. What would you suggest? We do or we leave this part? I think you know how to do it. So, but no, that's not a proper way. I'll have to do it. Okay, so uv minus integral v tan theta du sec times tan, sec tan. So taking tan. So this is going to be square and this is going to be sec. And here's equal to. So what we're going to do, I know this is going to be 1 minus sec square. So this let me say sec theta tan theta minus integral 1 minus sec square. When you multiply, it's going to be sec cube minus, just a sec. Because look, this is like 1 minus sec. And then when you multiply, it's going to give you, no, it's sec minus 1. Yeah, sec minus 1, not 1 minus sec. It's sec minus 1. Sec minus 1. When you multiply, it's going to be sec cube, and this is going to give, when you multiply by this, sec cube, and then you multiply by this, is going to give you sec. Okay, here is this what we want to differentiate, because this part here we know, only this part, which is integral of sec cube. Integral of sec cube d cube. Okay, so I can open this, it's going to be negative, but this is going to be plus. Okay, plus. But this and this is the same thing, so it's going to come in, it's going to be 2 of these equal to sec tan plus, because this is plus. When you integrate, this is going to be ln because integrate ln of what of sec plus tan. Okay, perfect. So what I'm going to do, we can replace this integral of sec cube. So the integral of sec cube, because look, this divided by 2 divided by 2 divided by 2 first. Divided by 2, it's going to be this divided by 2 and this divided by 2. So what I'm going to do, if I have to replace this, I'll plug in here. So this is question number 2. I hope you understand. So this is going to come in here and then we minus that. So finally, this stuff here, when you, is going to become equal to, let's replace this one here. Okay, so this is like integral. Okay, come and replace. So your replace is going to be 1 over 2 sec tan. Okay, plus a half. Look, a half of this minus this. Look, a half of this is the same thing. Minus, look, if you have a half x minus x, what you get is going to be minus a half. So a half of this minus this is going to give us minus a half, because the same thing is similar. Can't you see? A half ln of sec tan, a half ln of sec tan. So it's going to give us negative a half. So it's going to give us negative a half ln of sec plus tan. Okay, so the question is done. So what we have to do now, go back and substitute the theta like how we always do all the time. Okay, so small triangle. Okay, small triangle, and then how did you let? We let, it was A, because this is sec. No, x equal to sec. Okay, so now, this one we know, this one we know. The only thing we want to get is tan. Okay. I can substitute here. Sec square. What is sec square? Means x square. Equal to tan square plus 1. Come over, so it's going to be x square minus 1 square root equal to tan of theta. Oh, so tan of theta equal to square root of x square minus 1. Oh, for that case now, I can substitute everything now, because I know my sec, I know my tan. So this is going to become the final answer what we're looking for. 1, 2, no, with no limit, because, 1, 2 now, because in x square minus 1, the x equal to a half. Sec, what is sec? Sec equal to x. Tan equal to this, square root of x minus 1 minus a half ln absolute sec equal to x plus tan x. What is tan x? Square root of x minus 1. And you plus your constant c. We're done. Now we go to question number 10. Question number 10. Question number 10. Okay, question number 10. So question number 10, guys, that's also sec. So I'm gonna skip that one. Let me go question number 11, because that's almost also sec. Just no substitution and then question number 11. That one is tan. Let's do that one. That's very interesting. Integral x squared. So this is gonna be our question 10 now. and then dx. So what I'm going to do first and foremost, I have to make this as a, look how I'm going to do. So this time I say integral of x squared square root of 3 square root dx. So this is going to be tan because same thing square. So we let x equal to square root of 3 and then tan. Okay, differentiate dx. Dx equal to, when you differentiate tan, you get x squared. Okay, plug it in. So integral x squared, we know x square is going to be square root of 3 by square. Okay, tan plus plus. This one, you remember how it is? Dx, what is dx? Dx equal to this one. Okay, this is going to give us this, and then sec. You can do slowly. All of this is going to give you this. You got square root of 3 here, so all this is going to give us this. Square root of 3 sec. So what we're going to do now? Oh my God! Okay, better tracing. This and this is going to, okay. When you trace 3 times 3 is going to give a 3 outside. It's going to be sec times sec. Okay, I'm not going to do this, you know how to do it. By part. I just did now. I definitely believe you learn how to do things. If you face me, leave a comments under comments and tell me what did you learn from me, and if this video was helpful, if it was very entertaining, and if you got that, man, this man is like it's flowing, or you learn something from me, I believe you will learn from me, and also want to learn from me. If you identify any mistake, just let me know right underneath. Like, look, you forgot the under root, you forgot to say plus, you say minus. Ask any question, okay? And like I say, man, we dedicate to put a lot of time. If you don't know, I'm working on now to get some good equipment. So your donation means a lot to me. It could be $1, $50, $200, $2, 60 cents, 50 cents, 20 cents, even 0.001 cent, even if you want to put below, it's cool. Thanks a lot, man. I appreciate it. If you're new, subscribe and share. Okay? Peace. I appreciate it. Bye.